um, your phone's called physics balls, and you throw these balls against the wall and they rebound and they hit these geometry shapes, and you have to hit them a certain number of times to pop them. But again, I want to talk about ricocheting and how things bounce off of a wall, especially when you're not bouncing off the ground, because when you're bouncing a ball off of the ground, you have the spin involved, you have the friction of the ground, how hard you threw it. So the games like 8-ball and this ball are a little bit more straightforward. They're going to be sort of like the 8-ball game. So here's an example of the game. The balls on top are going to be shot out, and you get to choose where. So you get to adjust. And all the games that are like this, when you're shooting something against a wall, they follow the same geometry rule. So how do we know where it's going to rebound? Just like in the 8-ball game, what we do is we're going to make congruent angles. So we imagine the idea of isosceles triangles and even sides. And the angles on both sides are going to be the same. So if I first drew a straight line down, oh, that's not the right color. It's not going to show up. I'm going to draw a straight line down so we can have an idea of what triangle I'm talking about. And I'm going to imagine where the ball will rebound. I will make that green. So when the ball rebounds or goes off of the wall, how do we know where it's going to go? So it always follows a certain physics, is what we would call factoring in the angle and the pressure or the force of the ball and the friction of the things that it's hitting and rolling against. But for these video games, we just make things sort of bounce as if they're on ice or rolling. And so the way it's going to go is, it's going to be an estimate for this one, let's say. It's going to hit the number 6. Now what I'm looking at, if I had a compass, you could do it really great and you can make it perfect, but a lot of people, I'm so impressed when they play these games, you develop ability to just see it. You have an eye for it. And this also is something that helps you in photography and in other things as well. So this angle here needs to be the same. That's how it's going to rebound. And I could kind of see that I need to make it a little bit different. If I turn my head sideways, and if you turn your head sideways, you could see that's going to make what we would call an isosceles triangle. So this side on here that's dotted and this side here are congruent or equal. So the angle here on the side of the wall and the dotted part, this angle, okay, is always going to be the same as the rebounding angle that is made with the wall. And using the isosceles triangle, we can kind of get an idea. Now, just like in pool, a lot of times the ball will continue going, or whatever you're throwing, so you would just have to imagine it. So it doesn't always stop there. In pool, we could stop the ball here. Okay, depending on how hard we hit it, it would follow that path. It could land anywhere on this path and would continue going until it hits something else to get in its way. And then when it hits a shape, it will follow the same rule. It's going to make isosceles triangles on each side of the wall. So just a short little clip to make you better at games, but a lot of times we don't realize when we're playing some of these games we're internalizing the basic geometry we use in a lot of things in games, but also in construction, in photography, in architecture, and a lot of different things. So that's how we would predict the angle for the game called physics balls.